Rochester, Minnesota, and we're going to do a demonstration on the Rainfall simulator setup. We've delivered a trailer, and we'll go through the trailer and set up on the demonstration and some of the tips and clues on how to improve their presentations. We designed the tank so that it's a 65-gallon tank, so it's not too big, but it should be enough to run 2 demonstrations plus have enough water to clean up the mess when you're done. It plugs into the side here. There's a little 4-prong plug there. We tried to set it up so that you have as much versatility and with the unit as you possibly can. They've also got adapters so that you can hook it up to your battery on your truck, plug it in the cigarette lighter, what have you. And then you also can plug it into the 110 with the power adapter here. It's all a 12-volt system except for the 110 converter there. We use 2 pumps on it. The tower and stuff hangs here. The table will be here. The pans are in this side of the trailer. Pull the pins and it slides down. Put the infiltration trays, the funnels and the brackets and the covers all in these trays here, so it stores away real nice. It's a tub for some of your accessories, the power units and the pressure regulators and connectors. You have a battery charger. The battery charger is outfitted with the same 4-prong connector here. The template to cut samples is back here. Then the jars hang in front up there. So I guess let's set the table up. If you lift the leg up, it takes the pressure off the pin. And swing that one down. There's a groove on the bottom of this board, and that just fits in these. You center that up and that just snaps in the top there, and these hold in there, and that keeps the bottom of the board secure. These T-bars, they're adjustable. That's to adjust the height of your pan. Now there's no real magic as far as the height on that. I think the second one's about a 6% slope. If you have a really a level area like river bottoms in fairly flat, you can level those out. It's just to kind of match whatever demonstration you have and what you want to show. And making sure that you set the demonstration up so it's realistic and has the impact that you want is very critical, and that's why practicing with it and understanding what's going to happen with it is a good way to go. Probably the most critical thing that I like to emphasize in the training is that the best time to show raindrop splash and how soil is displaced is when this board is dry, because the first time when you first turn on the simulator, it's going to splash up there, but when it's dry it sticks, and then you have water flooding down over the over that after you've run it a little bit. So you'll see that initial stick. And so I try to get everybody to point that out from the very start so that it's, then people will watch that throughout the whole program. You'll notice when you're running this that you've got soil going everywhere. And that raindrop splash is so important because everything that you talk about on surface loss and the impact of what the raindrop is that's filling up all your pore spaces, it's splashing the diseases, everything that's going on with that raindrop splash is all being shown right there. So, and usually your center gauge should get a little bit more because of the angle that the water's hitting it. So don't be afraid to explain that. And the same thing is with these pans. So the reason I don't want to see the bare soil pans on the outside is where's that raindrop splashing the soil and the extra water. It's all going off the outside of the pan. So if you have a grass or 100% cover on the outsides or the more durable systems on the outside, then you don't have that loss. And because your goal is, and your demonstration is what goes into the jars. The only way to improve soil is to stop the loss and stop the degradation to a point where it's below what the improvement is going to be. I like to put the tower up as high as it'll go, and then it gets more clear. Because when you have a little breeze like we've got like now, then you're going to have a little bit of wind drift. If you're going to do a 5-pan system on it, then make sure that your most durable treatments are on the outside edges. And then if it does sweep over that, you're still protected from that and it's not going to matter. But those pans that are highly erodible, they're going to notice that. They're going to say, well, that one's getting way more water because it's going to be running off. Well, you're capturing all the rest of it. So put those either 100% cover and your grass pans on the outside and then work your way in. I like to start it and run it before I put any soil on here, so that I can make sure that I want the spray to pass the ends of the table, so that it's not actually making a turn over those pans. That's the first thing a farmer is going to notice. If that's his pan, if that's his soil, that's getting more soil, or that's getting more water on that, and that's why it's running off. It's not because there's anything wrong with the soil. You gotta keep in mind what you're doing is you're kind of messing with what these guys believe. And I've had people come tell me after a session, it's like, I've been farming for 30-40 years and you just changed everything I knew about soil. And that's what we're trying to do here, but we want this as correct as possible, something that doesn't give it open to a lot of critique, because it is a pretty strong thing when you think about somebody that's farmed that long. And you think about it is what you're trying to do as a conservationist. You're trying to set up a farming system that will withstand all the catastrophic events we possibly can. And if you have one rainfall that matches that, which I don't know any place in the country that doesn't do that once in a while, if that system breaks down under that water, then you start all over again. It's a demonstration of extremes, usually up to 1.5 to 2 inches in like 20 minutes. Another thing I like to do is when I'm setting this up, if I'm going to do a 5-pan system, is I like to do what I call my first rain, second rain demonstration. So I'll take the same soils, especially like a conventional tilled soil, and I'll put that pan right in the middle, and while I'm doing this little test, and I'll run that pan until I almost have runoff on it. It starts to shine, and you can start seeing it starting to puddle on the surface. And then I do this test, and then I shut it off. Well, that has a chance to settle, and then that soil is going to crust over for that little short period of time. You might put less than 1/4 inch of rain on it. But how many times do you have that quick little shower, and then you get the big blast? What I primarily trying to show is the most vulnerable time on a farmer's fields after they've planted it. And because there's nothing growing, and especially if they're in a conventional tilled system, they've worked that down to the point where they've got a nice smooth seed bed. They don't have any chunk soil. There's no armor on that soil whatsoever. So I want to show them where that one goes with the first little dab of water on it. And so, because once they've planted it, they're not going back out there if they can help it. And so that's why, you know, we used to use the old rotary hose and stuff to try to break that crust so to take more water, right? Well, so that's what that's for. So I would do like a conventional tilled pan wet and a conventional tilled pan side by side, just the very same soil conditions. One just had a little dab of rain. That way, if you do have a little bit of wetness on it, then you can explain, this is what happens the first time it rains. Now let's watch the difference on how much faster this runs off compared to this one. It'll run off right away. It just starts because you've already sealed all the pore spaces open. So next thing we're going to do is we're going to turn this on and see if it's adjusted. There are some adjustments up here that you can make if you need to. If the nozzle's not spraying quite as far over as we want it to, then you can put a wrench on here and a wrench on the block that the nozzle's screwed into and adjust it a little bit. It doesn't take much. You start the oscillation first. That way, when you turn the water on, then you don't get a big flood in one particular spot. Now there's a pressure gauge up here. That's already set on 10. What I look for when I'm running this is I watch the end of the table, and you can see it has like a splash stop splash as it passes. I'd say this one's pretty good. And it's an 80-100 nozzle. And so at 72 inches above this pan, the surface of the pans, at 6 pounds of pressure is supposed to give you a replicated actual raindrop impact with the velocity and size. So what we're trying to do with this is keep any extra water from getting into that infiltration tray that's going to go into the infiltration jar. Because to be realistic, you want to just capture what's going through the pan. You want to hold that tray and center that pan right over those trays like that, and then try to keep as much of the water out of that tray as possible. So next thing we're going to do is we're going to take this pan and we'll give you an idea of what I like to see in pan setup and filling them. So if I'm going to get something out of a tilled field, I try to just take the top surface, the surface inch, because that's the soil that's going to have the most impact. So I'll just scoop that off the surface, because it's that surface inch that is going to cause you the most trouble, because that's what seals up on you. So I'm just going to pull that, and and those pans, I do that because it's really quick to get them that way. I use the cutter to keep the integrity of a consolidated sample. A no-till tray, I'd cut it because you've got a consolidated condition you're trying to show. Okay, I'm going to go around the outside edge of this. I'm going to pack that really tight. When we built these pans, we put the funnels on them. We've got the front and the back of the pan are lower than the sides of the pan. And that gives you a good gauge of how deep to put the soil in the pans. If you have it too full and mounted in the center, then the water is going to have a tendency to run to the sides and run down the sides, or they'll run over the edges of it. So if you keep the goal in mind that the more water, the more that you get in the jars, the better the demonstration, then you just work with that. When I load these pans, I like to do it from the center out. Get that centered up. Okay. When you're setting this up, you try to line that up just over the center as close as possible. Depending on the slope that you have here, it's going to make a difference in how fast the water runs out there. There are actually two different notches on this bracket that you can move back and forth depending on where that's at. If you don't get it lined up and the water's not getting in the jar and is starting to run off, don't hesitate to stop your demonstration and fix it, because that's your show. Some of these people you only get one shot at, and so you want to do as good a job as possible. They have the T-bar back there, and if you push this back too far, your pans will drop off the lip of the table, and then you got to start all over with that pan. So before you ever put any of the tray or the pan on there, put this bracket on, and then everything can just slide up against the bracket, and then you don't have to worry about readjusting all that. Now in these pans we have, you can see we have a lot of cracks in this, and I'm not going to do anything with that. Let's just see what happens with that. And because this is a crusted surface that you would normally see after the first rain or after several rains, looks like with this. And then, so then this one's this soil back here, and this was a no-till soil. They've run these two already, so it'll be interesting to see what we have with that. The middle one is just this forest soil behind the parking lot here. What that is, you know, your construction site and all sorts of things. But when it comes to urban work, that's the kind of stuff you're going to be dealing with. So we have one that's got a permeable concrete. And we have one with a sealed asphalt. And we have a tray that we've made with shingles on it, and then you would put like a lawn grass in it. It makes a really good demonstration for city and schools and stuff if you're working with water quality issues. Now you can spray dyes and stuff on it to show what the runoff looks like, oils and things like that. So you should start pointing things out before you ever start to run it, because they don't see the same things you see. So just be real open about what you're going to observe and the things that you've already seen in other demonstrations you've done. And so tell them to look at what happens to the aggregates. See what's happening with that. See how fast it runs off. See if we can tell what's going to happen with that. A lot of people will like to put a quarter out there. They might use a dime, and as conservationists for years we've talked about the thickness, the soil loss, the tolerable amounts, the thickness of a dime, and that's like 5 tons of soil. Well, you can stick that in there and you can hide that a little bit, and when that shows up you can show how much soil's lost. And so you're looking for when that porosity starts to break down, you're looking at the point of where it's starting to puddle and where the soil is actually going to start to move. And then when it starts to move, then you can see what's happening with that, because you're going to have sedimentation, you're going to have a little bit of real erosion, you're going to have all the processes will be on these pans. You'll also see there's a raindrop compaction, because a pan like this, it looks all soft and fluffy right now. Well, when you start pounding that with rain, pretty soon what you thought you had a full pan, you may lose up to a ½ inch of surface depth on that pan, just because of how those aggregates start to fall apart. Now see, the first thing you notice is some of the stuff that's splashing up, the soil that's splashing up on the backboard back there. As that gets wet, then it's going to start running down the surface. The other thing I start seeing is like this one over here, the center, it's already starting to show a little gloss and gleam on it, like the water's starting to, it's not actually penetrating it like I expected it to. There's quite a bit of sand in that. The stuff that always surprises me the most is the sand. Okay, now this one's already started to, it had a little bit of a crust on it. Look at the raindrop splash behind that. It's getting quite a bit. It's already starting to puddle on it because the surface of that, the porosity is already broke down on it. And the only place there's any opens, actually the water's going through the cracks. I expect that probably will seal over fairly quick. They have two boards, one to give you the contrast if you put it behind, but it'll also hang between the jars. And a lot of people like to put it between the jars so that you can't see those infiltration jars. And then that's kind of a surprise moment, is that you pull that off at the end of the demonstration and show how much water is actually in the infiltration. You'll see all the soil coming into these funnels, and if your pans aren't completely full, you want to make sure that you can try to get them so that when the water runs down to the front of that pan, that there's enough soil in it that it will actually run over the funnel. Otherwise, the water has to stack up in front of that. This is where I would shut it off and do a little patchwork on it. This is a good example of what poor pan setup will do to you, because we can see here we had some gaps, and you can see how the water is actually running through to the cracks on the outside of the pan here, and kind of expected to see that. But so what we would want to do is, before you would run a sample like this, you would go around the outside and pack those with soil so that it doesn't do that. Okay, we're going to put another inch on it. They've got quite a bit of shrinkage on them, so getting them to run off, we'll have to fill the front part of the pan up with water before it'll ever start flowing over the surface of it. Okay, I'm going to go ahead and shut it off. You want to run it until you have enough variability in your jars that it shows what the demonstration is supposed to be. And so, like if you want to run this one so that you've got maybe half full or so, and maybe, you know, your infiltration jar half full, that may be enough. If you're going to do a large meeting, a big conference, or something that you want to make a really big impression of, is use soils you know what the results are, and have those soils ready to go way before time, and collect them early so that you can have that impact. Don't do this as an experiment when you're doing a big crowd. Get that lined out so that you have a good show and that you're confident and your pans are set up properly. But when you're going to a field day, put some stuff on there that's local and that's pertinent to what your demonstration is. Go out and do your slake test and try to get an idea of what's going to happen out there, but then do a really good job of preparing your pans. I figure if I'm on site, it's going to take me about an hour and a half to get everything set up. Just keep in mind, you are the professional. People are looking for you to tell them something that they don't know, and you're the educator, so the better you do that, the better it's going to be. Okay, let's have a little bit of a look here, see what all we've got. Well, that compaction layer is not just the compression from wheels and equipment going over the days. Is those particles don't just separate on the surface, they also move down through the soil. And as if you have free-flowing water into a tightly aggregated soil for a short period of time, those clay particles will hit that restrictive layer, and that's where they settle out. And in those compaction layers, there may be an inch to 2 inches thick, where we call it the plow pan. Well, that'll never leave, because that's a textural change as well as a structural compression, but you've got a textural change there too. So the only way that you can fix that is a growing plant. Having that root system and the earthworm channels and all that sort of go through those compaction layers, the only way that you can actually get water to move through those consistently and stay consistent. The importance of that no-till system is not just to protect the surface, but it's also protect that groundwater and that water movement through the soil. Okay, so we're ready to flip. When you do flip these over, do it quick and in a continuous motion. Otherwise, you'll end up in a big mud pie. So flip it quick. It's all soaked in on the front on that. Okay. I like to show them what I call adhesive versus cohesive soils, and look at the difference in how it's sticking to my hands. You have like an adhesive soil that sticks to everything else, or you have a cohesive soil that sticks to itself. You can see how the water starts to break down those aggregates, and see, so now then you can see why that surface would crust when it starts to dry. Look at how that starts to fall apart. And so you take that out, it's like, here's what happens to your moisture. There's nothing that holds that moisture intact in your soil.